All right, I think I've got some schematics here. I don't think I have the volume 8 stuff downloaded yet. But that's the closest that we have for CPU schematics, I think.
Yeah, volume 8 is just a bunch of text, so it's not a huge help at this point.
Yeah, we need to like sit down and figure that out. Bob coming in with all of the gift subs. Thank you so much, Bob. That is awesome. You are a legend, my man. Feel free to key up your mic too, dude. I love hearing your voice.
Hey, how you doing, man?
How's it going?
Rough time right now, but overall okay.
I feel that, man. It's that things are not great, but I'm not dead, so there's that at least.
Exactly.
Yeah, I gotcha. Well, I hope things start getting better soon, my man.
Too. Hope all is well. My wife saw a bit of your video the other week and dug it.
Bit of which video the other week? Would that have been the microscope one?
Yeah, I think whatever the last one you posted is, I was watching it. She came down. She was looking. So, okay.
Oh yeah, that would have been. I think that would have been the microscope one. That one was really interesting because it started off. It like tanked. It was like ranked 9 out of 10 or something. Like nobody was watching it, and I went through 5 different thumbnails, and I finally hit a thumbnail that clicked, and now that one is at like 70,000 views. Like that one really took off. So it just goes to show that like the content of the video doesn't mean anything. It's all about the thumbnail.
Yeah.
The thumbnail is absolutely everything. All right. I think, just as I said, I think we're stable enough. I just started vomiting frames. But maybe that's because I moved the camera. All right, I think we haven't had a disconnect for like 3 minutes, so I think we're stable enough to get started. I
need to reload because
Neo Dragon. I need to just open that up over here. I don't know why. I'm like trying to read the tiny text on my laptop over there. I just need to open up Twitch chat over here. There we go. Because I think somebody subbed and I didn't see it. I mean, we got all those epic subs from Bob. But it doesn't show it on this side, huh? I think, yeah, Neo, God, it's so small. I need glasses. Neo Dragon 90, thank you for the tier 1 sub. Kind of flubbed saying thank you on that one because it was so far away. What's up, the Flatulist? That's a hilarious name. Greetings from Texas as well. All right. Telenog gifting some subs. Thank you. We hit a hype train. What's that about? That's awesome. You guys are welcoming me back in style. Thank you. Thank you so much. The gold taunted you. I think that might be a little bit of Twitch manipulation on purpose. All right. Well, first things first, we got to get this memory card out because that's the one that exploded. And if I remember last week, not last week, 3 weeks ago, it has been a while, we did decide that we are missing a 19-volt rail, but that's the only thing that we're missing. And the reset switch isn't really set up like a reset switch, even though it kind of needs to be. But the reset switch has an auto pull up on it. So it should just come out of reset. Now the 19-volt rail, I'm not sure how vital that is for the CPU to come up. Because if I remember last time we were messing with this, we were going, I'm not sure if that 19-volt rail, like how necessary that 19-volt rail is. I did not order a 19-volt power supply. I should have. I might have a spare old laptop supply somewhere.
That'll work.
I mean, I can check upstairs. 19 volts kind of a weird voltage level outside of laptop supplies. Yeah, but we were pretty certain that we did need that 19 volt supply, but I don't think that 19, because we created it with the bench supply and it wasn't even pulling any current off of the bench supply. So that was a little interesting. I don't know why that was the case, because we hooked up the 19 volt supply to the pin that said it was supposed to supply, and we didn't get any current draw at all out of it.
Hey, Dave, is this a discrete component CPU or is this a chip?
It's pretty much all discrete components. I don't even think there's like a 74181 on it. I think it's all discrete. It's all 7400 stuff.
Yeah, there's 181s and 182s in there, or a 182.
Okay. Power supply, output. Next man. Where's the electrical drawings? That's the one that I need right there.
Volume 7.
Yeah, I'm trying to find the 4K memory card schematic.
That's on volume 7 too.
Yeah, I'm just trying to figure out where that 19 volt goes.
For some odd reason, I can't get to live. I reload the page and it takes me back to old stuff.
What do you mean? Oh, on Twitch?
Yeah.
I mean, we should be live on Twitch. I think, does anybody else having issues? Like seeing me on Twitch?
It's live.
No, I see it. It's fine.
Okay.
Fine for me.
I did have to shift refresh it once.
All right. Yeah. Yeah. It just sounds like Twitch is angry at you specifically. Twitch just picked one person at random and was like, nah, F that guy. Which sounds about right. Discord does that to me regularly, by the way.
Oh, really?
Yeah, Discord singles me out, and they're like, "Nah, we're gonna mess with this dude today." Thanks, Adam, for the Prime sub.
No,
Solder and
no
code.
problem.
There we go. I'm doxing people just left and right today.
Oh, it's not a secret. I'm amazed you remember all the different combos.
I'm slowly getting there. Every person that I meet online actually has 3 names. There's the name that they have on, or it's actually more than that. It's like, because the name on Patreon is often different than the name on Discord, which is different than the name on Twitch, which is different from their real name. So it's like 4 names that I got to remember for each individual person.
Mine's kind of
Were you
simple.
quoting T.S. Eliot there, or
No, was that a T.S. Eliot thing?
he has a poem about every cat has 3 names.
Okay.
That's what it is. He's got a poem about the naming of cats or something like that. It's
I could see that.
yeah.
All right, I am curious where, if our because our 19 volt should pull a ton of current, because that's what like all of the memory chips require plus 19. Thanks for the tier 1
Well,
sub,
it
Thrasher.
says 16.
Well, so if I'm looking at the schematic, it says the ICs have a plus 16 and a plus 19.
That's right. I remember that from last time. Yeah.
But I swear we hooked up the bench power supply set to 19 volts, and it showed pulling precisely 0.00 amps.
True.
Do we have continuity from the pin in the memory slot where the 19 volts is supposed to be to wherever the backplane says that the input's supposed to be?
Yeah, that's what I was going to check. I'm just trying to discover. I'm trying to remember where all of the correct what all the correct pinouts are.
I hope it's not something dumb like there's supposed to be a jumper that's not there or some crap like that.
Yeah, or this is a later revision that uses slightly different chips that doesn't need the 19 volts. That's possible. Let's see here. The RAM IC, it's going to be pin 10.
6.2.
And then if I'm looking at this right, I think that's actually the plus 19.5 that comes in on P170, 172, and P2, 9, and 10.
The other thing I just thought of is I wonder if this is related to the battery backup option in any way, because that would want to preserve memory contents. Is there some kind of logic somewhere that switches that 19 volts from being generated off the battery to this?
That battery voltage control, I think, comes through the +5 standby, which we've got wired high. So the actual logic that's coming in to tell it that the battery voltage is that we've switched over to battery voltage, I think is always set up to be fine. I seem to remember us running through that before. Where's my PSU schematics?
Yeah, no, I know we did that for the processor's sake. What I mean is, it's like the battery is what, 12 volts? Okay, they'll be synthesizing 19 from that somehow to keep the memory alive. If the logic that does that synthesis is what is crapped out, it could be leaving the real 19 volts open or something like that.
Open 130 megabyte PNG or 130 megabyte PDF. I'm trying to figure out what pins. I'm trying to get the power supply schematic open here so I can figure out what pins go where.
That's also on the volume 7.
Oh, is it? Okay.
Yeah. Page 24. PDF page 24.
Oh, gotcha. Yep, there it is. So our battery, the battery plus goes into the. So the battery plus, Suzerain, to answer your question, now that I'm here, says that it's approximately 27.6 volts. And then that goes into the original controller cards where they generate all of the necessary +5 standby, +19, whatever, to feed on out.
Man, that had to be a really weird battery setup.
Yeah, that wouldn't surprise me.
It's just two 12-volt batteries. when it's charging, it goes up to 27.6. When it's discharging, it can go down to 24, 23, etc.
Yeah, 212s would give you 28, not 27 and a fraction.
Well, that's gel cells. I mean, well, not gel cells, but
I mean, the
I've always
schematic,
called them-
the schematic lists it as two 12-volt batteries, and then they say it becomes approximately 27.6 volts, which is a really weird but specific number. They've got like the two tildes to show approximate, and then they give you a decimal point. That frustrates me, by the way.
Yeah.
Yeah, essentially they're cranking in 25 volts into this thing, and then generating probably the plus 16 and plus 19 and minus. Well, I don't know if they use the -5 on the memory. Probably just the plus 16 and the plus 19.
The memory does use -5, I believe.
Yeah, but the only one that we were technically missing is the 19.5, I think.
Yeah.
So let's double check on the memory card here. Pin 10. I wish I could just follow the traces, but it's like a super multi-layer board. Let's check pin 10, see if it goes to the same P1, 71, and 72, and P2, 9, and 10. All right. Those are big memory chips. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're pin 10. All right. Well, pin 10 is not a no connect. That's saying something. All right. I don't know which one's P1 and P. Oh, so here's P1. P1 71 and 72. So 80, 78, 76, 74, 72. Yeah, that's definitely connected. And then 9 and 10. So 2, 4, 6, 8, 10. Yeah, that's also definitely connected. So 19 volts should be going into whatever, however many of this is, 40 ICs or whatever this is. So we should see some current draw. Yeah, Commodore Z, the bracing on this thing is ridiculous. It's almost like they put the bracing there thinking that the board was going to be laying on its back, but they put them all vertical, so the bracing isn't actually all that super necessary. All right. Let's see if that is indeed where we're going to the PSU pin 15 and 16, P1, P2, 71, 72, 9, and 10. So that's going to be memory board, your P2. So P2, 9, and 10. So 2, 4, 6, 8, 10, which I'm pretty sure is U. And that's going to be 16 on this guy. So 2, 4, 6, 8, 10, 12, 14. Yeah, all right. So we don't have a broken connection at the very least. So we should have 19 volts. I think we need to just figure out that while it's fresh on our brain. Get the 19 volts squared away. And just check that box off. All right, but I gotta go try and find a 19-volt supply. So you guys will still be able to hear me, but you're just gonna be looking at that for now, because I gotta walk out of the room. And I don't think, I mean, I got a bunch of mean wells, but I don't think any of them do 19. They're all up in the 20 volt range, 24 volt. And I don't think I can get the 24 volts down low enough for a 19. An old ATX supply. That's interesting. ATX supply is not going to help, though. Oh, come on. Yeah, that's not going to have any power supplies in it. I got a 12 volt to 120 volt AC inverter. I don't think that'll get the job done, though. Got a PoE injector. No, it's not gonna cut it. No. All right. What other options do we have? I mean, I should just order a 19 volt mean well, but do they even make 19 volt mean wells?
I'm looking at that and I think no.
Yeah, it's such a weird voltage.
I
Yeah.
think our best bet would be 24 minus 5 or 15
I don't
plus
think
5.
the 20. I don't think the 24 will go low enough.
No,
One
I
thing you
mean,
might be able to do is get a 15 volt supply and then just trim it up.
Well, I think we've
it
already
goes
got.
to 16.5.
Well, I've already got a 15 volt supply in there, and the 15s won't trim up far enough to get to 19. But I could
Depending on how they
take.
do it, you might be able to go in and actually change some of the resistors in there, because usually it's a trimmer pot. If you look at the circuit, often there's like some resistors that limit the range. So you could kind of cheat and adjust those.
That's not a bad idea. We could also just toss a 5 volt in series with the 15.
Yeah.
I don't know how that works for like varying loads. I'm sure that's not great for it.
Yeah,
'Cause-
it's kind of weird to me, but
All right, look at the box of mean wells in there. Let's see what we can find. If I do have one in here that's just like a dedicated 15, maybe we'll throw some juice in it and see how far up we can trim it. Because the data sheet says, oh, you can only trim it this high, but mean wells tend to outspec their data sheets.
Yeah, they have a tilde. And it's 16.5.
Yeah, there we go. That's an LRS 100-15. What else do we have in here? That's just a S25-5. I could put 3 of these or 4 of these in series. Yeah, I've also got a a nice 24 here, an S40-24, and I'm wondering if we can trim that one down to 19 as well.
Data sheet says 22.
Yeah.
Which might be closer.
Yeah, we'll try. Just 5. What else do we got? We'll try both the 40 and the 15 and see which one gets closest. And then maybe we'll have to do 2 times idea of mucking about with some of the internal resistors. I mean, it's not like I'm running low on mean wells here. So if we injure one, taking it apart and messing with it, I think we'll be all right. I mean, I kind of feel like it's safer to go, like, if we can only get to like 18 volts, I feel like that's safer than if we can, you know, it's safer to go undervolting than overvolting.
Yeah.
All right, let me see if I can find a danger cord. AC
Danger
cord to
cord.
test these with.
You know, if you get it to 17.5 volts, just put an AA battery in series. Just solder it right in there.
I feel like that's something that I shouldn't do on camera.
Coin cells?
Coin cells.
I mean, I could just put 2 9 volts in series and then just replace them regularly.
Oh, jeez.
Oh my gosh, do I not have a danger cord in here? Come on.
We used to call them widowmakers.
Yeah, an AC cord that just is
Yep.
cut open. Yep.
Yep.
I used to have one that like I kept, that was like a little 2-prong guy that I kept specifically for doing dumb things like this. Where did it go? Maybe it's in that box. Ah, there we go. Well, nope, that's the opposite end. Dang it. Well, it looks like I'm taking one off of this. All right. Note to self, don't shock yourself on camera. All right. Whew, boy, it is toasty outside. All right. I did all that mucking about and I didn't get a power strip to plug it into.
Uh-oh. Turn that off.
All right. Here we go. Oh, you gotta be kidding me. You gotta come up. Hopefully that didn't crash the stream. I had to unplug my laptop for a split second. And I know that it has about 8 seconds of life on the battery.
It's fine.
All right. We're doing the thing. We're getting there. We're fully in a weird tangent right now, but I think it's a good tangent. It's one that we got to do. Ugh. I mean, I'm thinking, you know, maybe we didn't have current draw because I just had bad connection on the bench power supply to the connection on the backplane. So like, you know, the right way to do this is to actually have a dedicated 19-volt supply. So let's get you out. There we go, that'll work. All right, let's see how accurate Meanwell's datasheet really is here. There we go. Charles, you can't hear anything? I've been talking pretty nonstop. Can anybody else hear me, or has it just been quiet?
No, it's just been quiet.
Okay.
I hear you just fine.
Oh, okay. Is the can't hear anything or just in repeat? Oh, that must be talking about something else. Sorry.
Yeah, talking about an RF repeater, I think.
Ham repeater. Got it.
Ah.
I was in stream crashing panic mode there for a second. All right. How low can we go? 19.15.
Wow.
I mean,
Close.
no, I mean that's on the money because it's 19.5 coming out of the power supply.
Oh.
Right? I swear that's what it is coming out of the power supply. Where's that at? Yeah, plus 19.5.
You're off by 0.4 of a volt, but or
I
three.
mean, I can
less
get it to
than
that.
3.
Yeah. Heck yeah, we can just use this thing to get our 19
Oh,
volt.
19.7. There we go. Yeah.
There we go. There's 19.4. I think that works. We'll call that a victory.
Yeah.
Heck yeah. Problem solved. Thank you, Titian.
How much
Titian
current can that
78.
one do?
This one can do 1.8 amps. Is that not
Okay.
enough? That might not be enough.
Well, for one board, it's probably not a problem.
Does the data sheet for the, let me just go ahead and unplug this. Does the data sheet for the memory chips tell us how much current they pull? Because then we can do some simple math. I don't know what the memory chips are.
1101's the first generation of dynamic RAM.
These are, on this board, they're MF 1103s.
1103s. Oh, that's right.
I think this board has the same on it.
Log in.
Yeah,
Oh,
1103s. P11, so Intel P1103s.
Yeah, well, we looked at, we couldn't find the Intel data sheet anymore, so we just went to the TI. I don't know whether I still have that page still open or not. Okay.
P1103 DRAM data sheets. Right. Access memories. 2104. 2116. It's not that to the math. Doesn't list the 1103. I got comparisons of the 1103 versus other stuff, but it's not the actual data sheet. Twitcher00, can you not hear me talking? My mic should still be okay. I'm showing it in OBS is coming through. All right, Jeff's can hear me. I don't know what's going on then.
Oh, it's fine at this end.
All right, you might need to, Twitcher, you might need to restart Twitch.
It's fine at this end. Yeah, I just heard myself say it too.
Somebody give me a data sheet for the love of God, man.
All data sheet.
I'm
I
like
had
finding
it up
like
at one point.
finding like brochures and stuff, but
Data sheet archive. Let's see. Continue. Come on.
I don't know what the TI equivalent of it would be.
It's 1103. Not a TMS though. Let's see.
Oh my gosh, I find like page after page after page of people talking about the 1103 as the first available DRAM. It's this amazing DRAM. Brochures, not a single data sheet.
Hang on. Okay. Um, oh, come on. There's a link to the page.
Oh, did you find it?
Yeah, on Discord.
Oh, hang on, let me open up Discord on this laptop. Disco.
Oh, wait a minute. No. Let's see. I'm on Twitch. I'm sorry. On Twitch.
Oh, I got it. Retired OMT.
Yep.
Exclamation point. Open link. Let's move to new window. That's the TI version.
Right.
So what do they list VBB as? VBB
It's all
minus
negative volt.
VSS is 3 volts. So on the TMS 1103, VSS is set to 16. And then 16 plus 3 gets us to 19.
Yeah.
Yeah, but does it tell me how much current it pulls? This condition, low, high level input current.
I hate it when they can't, when they don't let you rotate a stupid page.
Yeah, so I'm looking sideways.
Let's see. Microamps, milliamps, 45 mil, 38, 37. What are we looking at?
Yeah, I don't particularly know which one of these we care about. Supply current from VDD during pre-charge pulse width. Supply current from VDD, but that's all talking about, you know, VDD, which is 0 volts.
Yeah,
And then VSS is 16. Right, read cycle, write or read cycle. Yeah, it doesn't tell us specifically what VBB minus VSS. What a weird way to write this out, man. What a strange way to list your stuff.
picofards, nanoseconds.
All right, well, let's see here. This can do 1.8 amps at 24 volts. It's actually quite low.
Yeah.
I wonder if I have a stronger 24 volt supply in here. It's all 5 volt.
Oh, you were
5
on the
volt.
24 volt. I thought you were on the 15 volt. Okay. You were able to go down to 19.1.
Yeah, here we go. I've got another 24 volt supply here that is 2.5 amps. So that gets us a little more
That's even
headroom.
better. Yeah.
Yeah, let's see how low we can take this guy.
You've just got the 8K in there. So
yeah, if we can get this guy down to 19 volts, I'll go with the bigger one here, just because of, you know, the extra headroom.
Yep.
I know memory is thirsty, but I can't imagine this part of the memory pulling that much huge current, because I think this is probably just a bias.
We're looking for current
All right.
that's from BB.
Yeah, it's VBB.
Yeah, supply from VBB shows as 100 mils max per chip. And what is that, 18 bits wide? Or not 18?
16, I'm pretty sure.
Well, 16, but you've got error correction in there too. So there's an extra 3 or 4 bits. I don't remember.
So the number of ICs that we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 by 17 by
Wow.
8. So whatever 17 times 8 is, that's how many ICs we've got.
That's 8K. And it's only parity. There's no error correction on it. I'm surprised.
This one goes all the way down to 19 as well. That's not a problem at all. Yeah, we'll toss this 2.5 amp one in there. That's 60 watts.
Yep.
That's a pretty healthy amount.
And the highest current draw will be during a write, I would think.
All right, now I got to figure
It
out how
may
to
go
mount
up
this
and
guy.
down with refresh.
All right, let's put danger cord back over that way.
Line in the data sheet goes IBB supply current from VBB 100 microamps.
Where do you see that?
Page 3.
The 100 microamps, we don't have any problems at all.
The Richard mentioned that the manual says it's 0.01 amps full load on the 19.5.
0.01 amps per chip or 0.01 amps for the entire thing?
For the
Lot.
entire thing.
That seems ridiculously low.
Yeah.
I think that would match up with the current draw aspect.
Well, if that's the case, I'm going to use the smaller 24-volt supply then. It's physically smaller. I mean, it makes sense. I think it's just a bias voltage.
Yeah, it is.
All right. Let's see if I can figure out how to mount this guy. Let me get my bucket of bolts here. Surely I've got something in here that threads into this guy.
Might be small enough that the bench power supply was right. It's 0.
Yeah, I mean, that's entirely possible. If we're pulling that little, the bench power supply could have been on the money.
Yeah, your 9-volt battery source doesn't sound that crazy now.
Yeah, that might actually last a long time. But it sounds like this guy right here, it gets down to plus 19.5, no problems whatsoever. Ooh, not right. Let's try
The little fan looks like it got missorted.
the little what looks like it got missorted?
The little fan there in the bucket of bolts.
Oh, yeah. I don't know where that came from. It's been in there for a long time. Let's see. I found one that fit. That bodes well for finding a second one that fits. Yeah, there we go. Now the question is do those line up with something on the back there? Oh, I think it just might. I might be the luckiest person on the planet.
Wow. 19.5.
Yeah, there we go. Brilliant.
Yeah, 10 mils. 10 mils. Wow.
Well, we're going to overkill it, so there's that. Yeah, we're definitely overkilling it. That's a whole lot of power supply for it. But it's going to work. That's all that really matters. Now I need some wires. And I got to figure out what pin to solder it to on the main backplane thing there. And I got to get some wires. All right. This might be long. And then I need some nice long. You and nowhere near long enough. There you.
Wow.
Oh my gosh. I'm going through my box O random wires, trying to find something long enough.
Oh.
All right. That'll have to do. I got a wire that's long enough, but it's too small. I've got wire that I think is this might do it. I think that'll work. All right, let me cut you. Yeah, we're pretty low current, so I'm not too worried about wire thickness here.
No. Voltage drop is going to be negligible.
Yeah. Well, whatever wire I've got picked here is actually bigger than the wire wrap wires that they're using on the
On the back lane.
back lane. Yeah. So I should have been just judging my current requirements based on that, actually.
I was doing a little more looking around on the web about TI in Houston. That building that I infrequently went to, where I saw that automatic wire wrapping machine, was apparently wire wrapping backplanes for the 980s.
Oh, okay. So you saw the machine that
they
wire wrapped this backplane then?
Very possibly.
That's kind of cool.
Yeah, I didn't realize it. I mean, I had no idea that the 980 was actually being built there.
Yeah, I seem to remember that when I was talking to Granville Ott, he was part of the 980 was like, he was on that team and he was in Houston.
Oh, okay.
I seem to remember him saying that like the 980 was a Houston machine and the 990 was a Dallas machine, and they were kind of in competition with each other. And the Houston team ended up getting the 980s used in like all of the production way out in like Lubbock and whatnot.
Yeah.
Whereas the 990 team ended up getting their stuff into the the business consumer market.
Yep. Yeah, TI really lost out with the 99.4. The competition with Commodore really set them back.
Yeah, that's a whole story in and of itself.
It is, yeah.
The hardware was somewhat crippled. Yeah,
of course, that's too
with
short.
The whole GROM thing.
I needed to ask Commodore Z, if you're listening, about early Commodore history. My dad was talking to his old roommate and high school buddy today, which was, called him kind of out of the blue. And so dad was talking to him about, what I do. And he went, "Oh, I used to work. I did some design work on the very first Commodore."
Oh, wow.
And I'm like, "Well, now I know the right person to ask about that." Of course, this wire is too
Which
short.
first Commodore?
Well, that's the thing is, I didn't talk to the guy, so I have no idea. And
What?
that was just one of the things they talked about in their total conversation. So I have no clue which specific Commodore it was or what he did, but I know his name. So if I don't know how well known the early Commodore designer names are, but
Well, it was probably the Kim 1 or the PET, depending on what you consider a computer, I guess. But if you want to send the name to Z or me or whoever, one of us will know. We can ask Bill Hurd.
yeah. Well, I think this guy would have left long before Bill ever got there. I mean, Bill didn't show up until the 128, right?
I think he was there for the +4, and a few other machines. I'm not sure the exact dates, but he was later on.
Yeah, because I remember asking Bill, like when I was talking to him, I was like, "Hey, man, everybody always, wants to know more about your history at Commodore. It's like, but how long did you actually work for them? Like, I imagine you've had this like really wonderful career throughout your entire life." And he's like, "Yeah, I only worked for Commodore for 3 years, man."
And that was probably more than enough from the sound of the amount of pressure they were under there.
Yeah.
I mean, I can't imagine they're soldering stuff on the floor of Comdex.
Oh,
Yeah.
geez.
He has a great story about what he calls the $1 million wire. Because it was a bodge wire that he had to solder up, and they had to do, it was like a 2-cent bodge wire, and they had to do like 5 million of them or something like that. So that bodge wire costs $1 million or something.
We've got, I mean, yeah, some of the companies I've worked for, they will make me drop down from a 32K microcontroller to a 16K because it'll save $5 million.
Yeah.
Jeez.
You're like, but it's only a 20-cent difference. Like, yeah, but
Yeah.
we're making 15 million of them. Right.
4 cent, it was a 4-cent difference.
Oh yeah, I wasn't even, geez.
Because the numbers we all see at DigiKey and Mauser, like when you hit those 1,000, that's just the tip of the iceberg. When you're buying millions of parts, the numbers, it keeps dropping and dropping.
Yeah.
Yeah.
Well, this is an awfully
funny, when I
thin
worked for
AC line, but again, we're not pulling a whole lot of current here, so.
When I'm a hobbyist or working for defense, none of the suppliers will call you back because you're only buying 100 parts a year. But
Yeah.
when you're on commercial, all of a sudden, they're coming to you.
That's why it's always really cool whenever you come across a company that actually does cater to hobbyists. They're like, yeah, we don't make any money off of hobbyists, but we know that like they're important, so we take care of them. That's how you know you've got a company that's not just the worst.
And not just the hobbyists, the schools.
Yeah, not much money to be made on schools either.
But that's the next generation of engineers that are going to use your parts in whatever they're doing.
That is why Adobe gives students free licenses. Because if they can get all the students hooked on the Adobe Creative Cloud, when the students go into the working world, that's the only software they know how to use.
First taste is free, just like any drug dealer.
Yep. All right, let's get our ground linked up. This is
microchip used to be
terrible
really good.
because this is not color coded, but we're just going to pretend that it is.
For today.
Yep.
Today only.
I think we're gonna tap on this ground here.
Let's see.
Oh, come on. Yeah, you guys don't have a wonderful view, but there's honestly not a lot to see with my gangly arms in the way. There we go.
Well, since it's quiet, I learned an interesting lesson about air conditioners last week.
Capacitors go bad?
The capacitors go bad, that one, but if you get a power blink and you have a scroll compressor, it can just suddenly run backwards.
Huh.
All right.
And it turns your compressor into your AC into a heat pump for about 5 minutes before it pops the thermal cutoff.
All right then. I mean, our air conditioner out here is a heat pump, so it is kind of meant to run backwards.
Well, those have usually reversing valves. It's done with a valve because you're not running a compressor backwards. The scrolls is not good for it, but it won't instantly kill it.
Meanwhile, what are you doing to me, man? Meanwhile, changed the thread pitch on their terminals lugs down here between models.
Mm.
So now I gotta pilfer screws from a different Meanwhile. There we go. All right.
But I will say GE or whoever GE uses to make capacitors seems to last. The thing was from 1990.
Well, that's pretty good. Our whole AC like just kind of completely died not that long ago. I had to get the whole thing replaced.
That's what I'm rolling the dice on now. This is R22 installed in 1990, and everything's, as far as I know, original.
Yeah, you don't live where it gets to 110 though, which is nice.
No, it was 104 last week, and that was abnormally hot for early July, late June.
Yeah, I was gonna say that's pretty hot for up that way. I mean, we've been right at like 100 to 102 every day for the last couple of weeks. But I don't think we've had a day over 110 yet. It's been a really mild summer this year. Last year was not mild.
Likewise here in Sacramento, it's been really quite mild. I mean, just touching on 100 and that's about it.
Yeah, it's 74 here now, which is a lot more normal in the Northeast.
Yeah, I don't think it gets down to 74 here even in the middle of the night.
maybe at 4 a.m., but that's about it.
Future me is going to look at this and be very unhappy with the fact that I didn't color code anything, but present me does not care about future me. Let's grab
29.
Yeah, I was in Phoenix in 1990 when they hit their record temperature, 122.
Oh, jeez.
screw that, man. That's Dubai weather, man.
You don't go out
yeah.
for anything.
All right. The next step that I got to take is figure out where to solder this thing to the back plane.
Well,
PSU, it's pin 15 and 16. And I've got, where's my plus 16s? What pin number is plus 16 here?
3, 4, 5, 6.
Yeah, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, and then -5. So I'm on the one right next to -5.
Correct.
All right, I'm gonna need to pull that thing out, I think. Unfortunately. Of course, the purple wire that I have set aside for this, oh, it might just barely be long enough. Okay. Oh. I can't remember how to remove this thing. There are 2 screws on the bottom here. Remember for sure. And then what do we got? We got just one screw here, this one on the top. -5, yeah, -5 fills up 4 pins as well. So if we bring you out, I can see the trace that I need to get to. Okay. Right, these are 15, 16. So 2, 4, 6, 8, 10, 12, 14, 16. Which goes right through there. Let me just double check that I am on the correct trace. I have no idea what you guys are looking at.
Side of a power supply.
There you go. That's
Some guy standing behind it.
Yeah. All right. Yep. I can get to that. So I need to get a little bit of solder out. We're just gonna go straight onto this trace right here. I think we can do this. Go. And then I can sneak that right through that hole there. And we have our plus 19 coming out of the back plane. Coming out of the, what do they call this? The motherboard, I guess?
Hard to say. There's so many motherboards on that system.
I know, right? Keep making up names for them.
Power supply motherboard.
Yeah, it's like it's a
CPU
backplane for the power supply,
backplane.
and it plugs into
Yeah.
the backplane for the rest of the computer.
Yeah.
I mean, the good news is that even with now 4 Meanwells in here, this thing still weighs just absolutely nothing.
Geez, yeah.
The entire weight of the computer has just dropped by like 70%.
I just dropped 8 drives into a new NAS today. That thing weighs a ton now after putting those in.
Do you have to re-silver? When I did re-silver, when I did my when I upgraded drives on my NAS, you have to re-silver them one by one, and that takes like 15 hours per drive. And I was doing 10 drives.
You got a 10 drive?
It's actually a 12 drive, but 2 of them are redundant OS.
Oh, okay. No, this is brand new Synology. I set it up as a RAID 5 for all 8 drives.
Okay.
And so it's currently, I mean, I haven't even set up, I set up the RAID 5, but that's all I've done so far. It's supposedly, it's actively doing something. Well, it seems to be. Yeah, it's still doing it.
Are you running TrueNAS, or is whatever there, are you running their like proprietary software?
Proprietary.
Okay.
It's my second NAS from them. My first one is 5 drives. Got a hot spare running 4 drives as a RAID 5.
Okay.
and I just needed to expand, get more space, because I'm transferring all my DVDs and Blu-rays
How much?
because I don't watch them.
How
I don't
much?
spend that much time with them.
How much space do you have now?
On the new NAS is 73 terabytes.
Jesus, holy cow! All right, that's a lot.
12 terabyte drives.
Oh, okay. Well, there you go. I'm rocking 4 terabyte drives.
Oh, okay.
All right, let's get you out of the way. Let's just make sure that
Shouldn't those
nothing
drives
catches on
be?
fire.
Those 12s are helium filled. Shouldn't they be lighter?
There you go.
Yeah, they are helium filled.
All right, nothing caught on fire. That's good news.
I always wondered how they make that work. I guess they don't have the pressure relief thing that the old drives did.
I don't know what kind of pressure they have in them. It's probably atmospheric pressure at most.
You never know, man. They might pull that to a pretty low pressure. I mean, they always say that like neon tubes, you know, like neon bulbs and whatnot are neon filled, but they're really not much higher than vacuum pressure inside of there.
Yeah.
The fact that they use helium too, though, rather than like something cheap like nitrogen.
Yeah, I think the N2 molecule is bigger. So helium's better because the molecule's smaller.
Yeah, except that helium is getting rarer and more expensive.
Yes, it is.
All right, let's see if we light some stuff on fire here. I did check all the voltages, and they're all on point. Well, we're exactly where we were, so we didn't make anything worse, it looks like. But when the whole thing is completely lifeless, it's hard to make it worse.
True.
All right, but that means that we can now... Huh?
No, you got an LED. You got an LED.
Yeah, we got a power LED, and we got our singular 14 over there that we've been getting for a while.
We're still shooting for 4 lights.
Yeah. Yeah, I wish. I would be happy with 4 lights. Oh, Discord, go away. All right. Okay, so at this point in time, I'm pretty confident that our power supply situation is sorted.
Yeah.
That's sorted, spelled S-O-R-T-E-D, but also S-O-R-D-I-D, because I made it.
One question. We got a 29 volt supply that I don't remember looking for and looking at.
I remember we were checking that and it didn't go anywhere. So we thought that one was internal, but I can double check that.
Yeah. No need. You look at the schematic of the power supply, and the bottom row, which is the backplane, doesn't go anywhere.
Yeah, but if you look at that bottom row on the backplane, that 19.5 volts shows that it doesn't go anywhere either, and it does.
That's what I mean. Yeah. Oh, it does.
Yeah, the 19.5 does. Like, so if you look at the backplane schematic for the power supply, it shows that pin 15 and 16 don't go anywhere for plus 19.5.
The 19.5. Yeah.
But
And
it
the same for
absolutely does.
29.
I can see the wire wrap wires on there.
Yeah.
So I can double check. But I seem to remember. Yeah, I seem to remember that we counted it out and they weren't going anywhere. So let's see here. 2, 4, 6, 8,
core memory.
12, 14, 16. 16 we got. Let's see here. Then 18, 20, 22, 24 goes someplace.
That's M reset.
26 goes someplace.
That's power off.
28 goes someplace.
Power reset switch.
30 goes someplace.
MP loss.
And then 32, 34.
31, 30.
Yeah, 31, 32.
31, 30.
Yeah, they don't have any traces. Or they don't have any wires on them unless there's a trace on the front side, but I don't think there is.
Yeah.
Yeah, there's nothing on 31, 32. So I think we're all right on that guy.
All right.
And then everything after that is stuff. And
5 volts.
Yeah. And I remember we checked the reset switch and the MP loss and all that stuff. And those were we were good on everything except for M reset. But M reset has an internal pull up.
So we're safe there.
Yeah, so it should be it should be coming out of reset like as soon as it gets power, and then we can pull that to ground if we want to run it through reset again.
Yeah.
So now at this point, I think we start chasing down clocks, maybe.
Time for the scope.
Yep. Unfortunately, can't really probe the memory controller card unless we remove the memory card.
Yeah. Clock circuits should still work. That's the memory card shouldn't stop that. I wouldn't think anyway.
Well, we should have some clocks on the memory card, right?
The memory controller is where the clocks are generated.
Yeah, but I mean, I can probe. What I'm trying to say is that I can probe the memory card, the 8K memory card. I can probe it really easily. So if we can chase down, clocks on the memory card itself, that tells us that the clock on the memory controller is fine, right?
Yeah. Let's see. 7475.
If I remember from last time, was the 12 megahertz clock running?
Yes. I seem to remember that we checked the primary 12 megahertz clock and it was indeed going. I need a power cable.
We started running into issues with the logic on the memory controller after that. Not knowing what was supposed to be happening when and where. Let's see.
You can go back in.
I'll interface.
All right. Off we go.
$15, $16 doesn't show.
All right. Scope is coming up. Yep. Let's grab 2. All right. Let's go back a little bit, bring you forward so I can still dig through you. Find a 4K memory card, which was like page, what was that? 8, 9?
4K? I thought the 4K was the dead one.
Oh yeah, the 4K is the dead one. The 8K is the one we're looking for.
It's the same circuit. It's just got more chips on it.
Yeah.
Same board.
So we should absolutely have, like RAS and CAS and all sorts of clock signals coming into this board somewhere.
RAS and CAS is generated locally.
Wow. Okay.
They got their own. It's got its own oscillator. Not even crystal controlled. It's an LC circuit. RC.
Boy, the 8K memory is really just 2 pages of schematics. That's it, huh?
Yeah.
Keep it simple, I guess. So we've got a
refresh is actually refresh is actually done on the controller, I believe.
Yeah, so we've got 4 chip selects lines that are coming in, a reset line, a write line,
Yeah.
pre whatever that is, PRE, and CEN, whatever that is.
CEN, chip enable.
Oh yeah, there you go. And then we've got a read enable and a write enable. And I think that's kind of all of our external signals coming in. Well, and a power on signal, which we should absolutely be getting. Maybe, hopefully. I mean, if the power on signal never gets there. Oh, that's our +5 standby thing, right?
Yeah.
There is a false clock and a true clock.
False clock and a true clock.
That's their way of saying there's a
lie.
They're inverted. There's an inverted clock. HSC LKA minus and HSC LKA plus.
Oh.
Is that on the memory board or is that on the memory controller board?
I think it's a memory controller. The 12, where the 12 megahertz oscillator is.
Yeah, that's the controller. I can't get to the controller yet.
Yeah, I'm reading it.
I can. If I remove the memory card, but I want to. I kind of want to start on the memory card and then work our way backwards from there.
No, you're fine. You're fine. I'm just reading ahead. I was or reading behind, I guess. I was trying to figure out what all that logic we were digging into last time was about.
Yeah, I'm just trying to figure out, like we're fully dead, so like something's got to be happening. Like even if we're just sitting idle and not in run,
Should be
Like-
getting refresh for sure.
Yeah, we should be getting refresh. So what's the refresh pin on any of the ICs? What is that going to be?
It's not. It's just you just have to address either RAS or CAS. I don't remember which.
Well, looking at the IC, we've got chip enable and pre, whatever that is, and then read write on a singular pin.
Pre-charge
Okay.
must be low at the start of any read or write cycle, and remain low for a specified time interval after chip enable drops to a low.
All right, so that's not a bad one to check because read or write, the pre-charge is going to be twiddling, right? Unless it's always low. I mean, I assume it's supposed to go high at some point.
Yeah. Let's see,
Well, hang on.
addresses.
Pre was up here. Yeah, pre-charge is up here. So that's pre-charge is going to be controlled via master reset, as well as the pre-charge signal and the chip enable signal coming from the memory controller, right? So if we see a pre-charge twiddling, that tells us that the memory controller is trying to do something.
What
True.
did you say the master? What did you say master reset was doing?
Master reset should just be high all the time. So it's not master reset
Yeah.
Master reset will essentially disable all the pre-charge.
Right.
But master reset's high all the time, so the pre-charges all the pre-charge NAND gates should be enabled.
Yes, you're right.
And then if we get a pre-charge signal with a chip enable signal, that allows the pre-charge to go through to all of the ICs. So if I check any random IC for the pre-charge signal, or if I check any of our AND gates, those NAND gates there, like Z48 or Z43. So any of those, or any one of the, I think I'll probably check it on an actual memory IC here. Let's see here. Pin 11 is ground. Oh, especially because I've got one that's like propped up. I've got great access to it.
Row address. Okay. Row addresses are the refresh, and that would be addresses 0 through 4
Pre is going
on
to
the
be
chip.
pin 5.
Yeah, pin 5 for the pre-charge.
Yep. Yeah, I just want to see if pre-charge is twiddling. If pre-charge is not twiddling, then that's an indication that our fell off. That's an indication that we have a larger, more worrying problem.
You can also check pins 1, 2, 3, 4, and 15 to see if there's any addressing. That would be indication of the refresh actually operating.
Right. It's a little precarious, but I think we're okay, maybe. I might have that might have moved. That's not great. All right. 1, 2, 3, 4, 5. There we go. All right. So let's see what the scope says about pre-charge here. Flip you on. There's some activity, but it certainly doesn't look like it's what it's supposed to be. So our pre-charge is twiddling, but it only twiddles up to about 1.5 volts.
That's not good.
Yeah, it is hitting at a
Alright.
specific interval, but yeah, we're only going up to 1.5 volts. And I'm on pin 10 for ground. Oh no, pin 11 should be
10.
ground. Hang on a sec. Yeah, I think I've got my
Okay.
ground on the wrong pin. That would make a big difference.
Yep.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, no, I'm pretty sure I was actually on the right pin there. Right? Yeah, pin 11 is technically ground, right? Yeah, pin 11 is
ADD.
ground. No, pin 11 is listed as G and D on the schematic.
Oh,
Yeah, it says VDD on the IC, but that goes straight to G and D.
okay. Ah, yes.
So yeah, same problem.
What do you see?
Same problem. I see what looks like logic, actual blips. But they only get up to, man, they're kind of all over the board. Sometimes they're 0.7 volts, sometimes they're 1 volt, sometimes they're 1.5 volts. But
What is the
nothing ever
timing?
higher
Yeah,
than that.
That's not a good thing.
The timing of it is
Tip enable, right. Pre. Okay.
The timing of it is every 67.8 microseconds.
It should be 62, so that's pretty close.
Yeah, that could just be me getting my cursor slightly off.
Okay, so at least, hey,
Yeah.
one of
So
two
it's-
variables is right.
Yeah, it looks like it's happening at the right speed. Nah, 62 microseconds is off quite a bit. So it's definitely at 67 microseconds. But that's close enough for me to think that it's trying to do something. It just seems like totally the wrong voltage.
Yeah.
Like 1.5 volts, nothing is going to happen at 1.5 volts.
Nope.
So let's scoot back in the line, maybe.
Well, let's just for grins, try and address the low address lines A0 through A4, 1, 2, 3, 4, and 15. That should show refresh.
All right.
That's the refresh rows.
I might be able to do that by hand here. So I'm going to be on a totally different chip, but
That's all right.
that's a real big signal. Pin 1 and pin 2. That's Definitely getting logic spikes up to 10 volts and some up to 15
That's
volts.
possible. That's possible.
Yeah.
Uh,
Well, I'm triggering on one from a 10 volt, but if I move my trigger up a bit, yeah,
let's see.
that's a proper logic spike up to 16 volts.
Okay. That's refresh. What's the timing between those?
Oh, hang on a sec. Don't short on anything, please. That would be 68.7 microseconds, same as before.
That's good. That's good. That's your refresh.
Yeah, that's happening, but our pre-charge is only getting up to 1 volt. That's a bit of an issue.
You don't need the pre-charge for refresh though. All you need to do is address the rows.
Where are you looking at pre-charge again? Sorry.
Pin 5.
Of the chips?
Yeah.
Yeah, the actual ICs.
And that may be coming up because of the refresh.
So it should be like 15 volts there. Right? It should be in the 15 volt range for the RAM.
The pre-charge?
Maybe, I'm not really sure. The pre-charge is fed. The pre-charge doesn't look like it has a pull-up resistor, so it's fed directly from the Z48, Z42, Z37, etc.
Yeah.
And my guess is that those are just like standard 74LS stuff.
Right, but very possibly open, probably open collector.
If it's open collector, then where's the pull-up?
Hang on a
Not
second.
sure.
Yeah,
It's a
Adam,
10
if you
ohm
follow
resistor
along,
in series with the pre-charges, but
yeah, that's not a pull-up though.
no, that's just buffering between the chip and the memory. But what are Z48 and Z43?
I'm just
They didn't
pulling it out right now to look. So golly, this thing is rough. Like, no wonder it doesn't work. I got so much corrosion on here, it's insane.
Oh yeah.
I got so much corrosion, it's hard for me to read the silk screen to figure out what chips are what. So I've got Z58, 50, 51, 52, 53, 54. Those are all, that's all Z50 range. That's not helping us.
Yeah. 44, 46, 48.
Z29, 30, 31. Z32, Z33, Z34, Z35, Z36. Just close, but no cigar. So it must be one of these guys down on the bottom. Which are the most corroded.
Are those memory chips plastic cases?
I think these are maybe ceramic. No, I don't know. They're lighter colored than plastic cases, but they might still be plastic cases.
They would be, if they're ceramic, they would have a metal cap. Metal top.
Let's see here. Z. There's Z37, which is unfortunately not populated.
See, what's telling me that it's open collector is the asterisk and the schematic in each gate.
Which document and page?
PDF page 10.
Is Z40 one that we care about? No.
No.
How about Z46?
Yes. That's a right.
Yeah, but that's different than what the others are.
Yeah, that asterisk with a circle is kind of weird.
Dang, man, I almost feel like I just need to clean my memory board here. This is just disgusting. Like, this is probably not great. Let me take a picture of this.
If you clean it, just don't rub off the paint, which may very well happen.
Yeah, there's also some weird stuff going on. Like Z43 is not populated on my board.
What?
Yeah, you'll see it in the picture that I'm about to send, actually.
Okay.
Friday Night Twitch. Oh, great. It didn't rotate, but whatever. So 2 things to note. Z43 is not populated.
That's weird.
And then there's a whole lot of really gross looking corrosion right above it.
Yeah, I see it.
Yeah.
75, 361. That's one of their interface chips.
Data sheets in the chat.
Oh, thank you.
I am going to scrub this for a little bit while we try to figure out what the heck is going on. Like, why is my Z43 not populated? And maybe that asterisk says that it's an optional thing, not that it's open collector or something.
TI was in flux when it came to how they did their indications of what kind of outputs they were running. Let's see. Dual TTL to MOS driver. Okay. VCC1, VCC2. Okay, that explains that. Okay.
So those should take it all the way up to the 16.2 volt rail.
Yes. And the fact that that's missing says a hell of a lot.
What is it? Well, like, what does it say? Like, it hasn't been removed. It just was never there.
Yeah.
It's not like, the board had a fault and somebody pulled that chip off.
Well, the others, no, they're not in sockets, so never mind.
Because Z37 is also not populated. And I think that's one of the ones that we care about as well. Yeah. Yeah, so it's like all of the pre-charge ICs are not there. Z40, what are you? Z43 maybe?
Z43, 48. That's what I'm seeing.
Yeah, what's the Z43 is missing. Z37 is missing. I don't know where Z42 is.
How about 48?
Or 45, 46, 47. Yeah, Z48 is also missing.
Son of a bitch.
Well, that explains the 0.7 volts.
Yeah, right. We don't have any pre-charge drivers.
Yeah. Does it? Can you identify if you can see any resistors that are missing too?
Yeah. Oh dang, the silk screen. So R58 is one that's definitely missing. R56 and R57, that might be a 5. I'm not really sure. R something 6, R something 7, R58 for sure, R something 9. Those are all missing. R60 and 61 look like they're missing.
Those are all resistors coming out of those drivers.
Oh, they all fell off for some reason.
Yeah.
You're sure they were never
I wonder
populated?
if certainly looks that way.
Geez, quarter watt resistors, no less. Jeez.
Like who would remove resistors and drivers?
For this specific section. It's like,
that just doesn't make sense.
But the other memory board, I mean, it only has half the memory, but it is not missing those driver chips like this one is. At least for the half, but it is a different revision memory board because it has different parts on it.
Oh yeah.
Like this memory board has these weird cordwood style things on it, and this board does not. It's like this 4K board is a newer board.
Huh.
And this 4K board is in, it looks to be in better shape actually, but it's the one that popped a driver.
Yeah.
Now we could pull that driver out and steal it from, this other board if we think that the 4K board is a better shot.
Well, it might be.
Which is closest to the schematic we've got?
You got me. This one has less corrosion on it.
I'm just surprised that they only had parity on these boards, because the ones that I worked with all had error corrected memory, so they were, instead of 17 bits with a parity, 16 bits with a parity, there was an extra 4 bits, I believe, per row for the error correction data. So you could have a single bit error, and it would correct itself. If you had a 2-bit error, you had a parity error. Or more, obviously.
I'm just looking at the page 12 of the PDF, which is the 8K board. They were up to revision note L, when this was printed. On the upper right hand corner, and they're messing around with those voltages.
Yeah. Yeah, we talked about that last time.
Yeah. Oh, and it goes beyond 12. It's continued on sheet 2.
Sheet 2.
Yeah, so the IC that blew on this is Z36. I think. I'm pretty sure that's the one that blew. I've cleaned off all the residue now.
42, 43. Oh, okay. 37, 42, 48. I was looking at the 4K board.
Which is what, a 7231A? 7231A? Do we have those on this guy?
No, I don't think so.
Now we've got 7423s on this guy.
7231. That may be a date code.
Oh, could be. Well, there's also 7536. So
7536. That's a real number.
okay.
If it's a 75 number, that's always a driver or receiver.
All right. So 75361. Oh yeah, there we go. These are 75361s as well. So I could totally replace the IC that blew on the 4K, and we could toss it in and see what it's doing. Because it doesn't have any missing ICs except for the the 4K that's not populated.
Right.
I mean, if we think that is a worthy endeavor.
Up to you. I mean,
yeah, I'm thinking.
I mean, how vital is it that we have functional memory in it for the front panel to come alive and for the CPU to do stuff? Like if we don't have,
good question. I mean, the controller is the real question is the controller reliant on the memory board being there with signals coming back? And I kind of don't think so. I mean, if it gets all Fs, who cares?
well,
It's
okay.
not looking at the data.
So with the 4K board, even if that chip is blown, as long as it's not shorted on one of the power rails, we should be able to plug it back in. Like, yeah, the memory won't work right because we're missing one of the driver chips for it.
True.
But as long as it's not shorting a rail out, we should be fine.
Yeah.
Now I don't know on a 75231 here. I don't know what the pinout is, but I'll just check.
75.
It's in the chat.
Oh.
I can give you I can read off what you want.
75231.
Yeah.
Oh, wait, no, that one's not in the chat. Sorry about that.
Sorry, I got called away. How are things going?
We're finding out that even though we have the schematics, we don't actually have the schematics because of revision changes.
Yeah, that's how it goes.
75231. Or was it a 361?
It might be a 361. I don't remember.
Okay.
75231's a core memory chip.
Oh, that's a dead short.
Yeah.
Oh, no, not
Just
a dead
clip
short.
the leads.
Yeah, that one's not. It's not shorted. I was just, my probe had slipped.
Oh. All right. 75, 361.
So pin 4 and pin 5 have about 2 ohms between them, but that doesn't feel. They all have
That's
that.
ground in VCC.
That's
Pin
not a
4
good thing.
Pin 4 is ground. Pin 5 is VCC 2. Actually, sorry. Because there are 2 voltage, 2 VCCs.
Right. That's another driver. Yeah.
But what is that shared with? Like it's 2 ohms. 2 ohms might be totally fine if that VCC and ground is shared with all of the memory chips too, right? Like these boards are going to be power hungry.
I would just clip the chip out of there. If you've got side cutters that you can.
I do, but I don't
clip
remember.
the chip right out of the. If you can clip the chip right at the case.
I can. The problem is that I'm not sure which chip it is anymore because I was cleaning and I cleaned off all of the residue.
Didn't it blow a hole in it?
No, it blew something out, but it didn't blow a hole in the chip, I don't think. Not that I can see. I'm pretty sure it was Z36. I'm trying to find a picture of it. I know I posted a picture of it.
Yeah, way back when.
Way back when it happened. So now I'm just trying to find that picture. Or at least when that picture would have been taken, maybe? Yeah, it would have been after March. Or maybe in March. All right. Discord. Nope, go away. Don't want to reply to myself. Let's search Friday Night Twitch from Soggy Electric.
Has image.
Has image, yeah. Unfortunately, I post a lot of images.
Yeah.
I'm on page 5.
Get to around March of this year.
That's where March starts on page 5.
Oh. That page 5.
That's when we were doing LGP stuff. Yeah, there it is. Got it. So, yep, it is Z36. It is the topmost chip. We know that chip is bad, so we might as well just go ahead and remove it. Go. Because we've done all of our testing with the other board because this board went up in smoke immediately.
Yeah.
So I'm kind of want to see like if we pop this board in, does behavior change? I need to go hit this with the air hose right quick. All right, I got some canned air here that'll work too. So let's see if behavior changes any at all by swapping to a different memory board here.
Okay, so it's the one with the brown goo coming out the side, right?
Yeah.
Oof.
Well, we don't get our 14 light. Now we get absolutely no lights whatsoever. Yeah, so that's arguably more dead.
Well, nothing exploded yet.
No, that's yeah. I suppose that's a. We'll take whatever wins we can get.
That's a good sign.
You still getting your any pre-charge pulses?
I don't have the scope plugged into it at the moment, but I can check that. Pre-charge was 5, ground was 10, right?
11.
11. That's right. Pre-charge is 5.
Oh, me sleepy one is asking if it could be a slot position issue. I don't think so. I
No.
know we've got the right slots.
No. As long as it's forward of the controller board. First 3 slots are the AUs and the controller. The
Yeah.
other slots are memory, but you've got to have full memory. Well, largest to smallest, basically.
Yeah, we've got our
Oh.
we've got a proper pre-charge now.
Yep. Yeah.
I like it. What is it? What are the voltage levels?
15 to 0.
Okay, cool.
That looks good.
Yeah, that looks like it's supposed to.
How about your just address 0, pin 1? Well, no, pin. What is it? Where is it?
I thought it was pin 1.
That was address 3. Pin 4 is address.
Yeah. We've got activity on 1, 2.
Yeah.
Hang on a
You
second.
got refresh going. That's good.
One of them doesn't, but 1, 2, 3. 3 is stuck at 5 volts.
Oh.
4 is stuck at 0 volts. But 1 and 2 are booking.
That's weird.
Yeah, 3 is at 5. 4 is at 0.
How about 15? That's address 4. That's part of the rows.
It's a little harder to get to here.
There it is.
That's stuck at 15 volts.
Oh. I saw negative going pulse. Yeah.
Yeah, that was
Okay.
Let's see here, the negative going thing. No, I don't know what you saw. I'm not getting anything out of these guys. I think you're just seeing my probe bounce up and down. There we go. That's 14, which has a nice negative going pulse. Keep in mind, we're completely missing Z36.
True. Well, pre-charge. What was that pre-charge?
I have no idea what Z36 does. What does Z36 control? Let's find it on the 4K board here.
Z36, 37, 38, 39, 29.
I mean, it's got to be one of the drivers to
36.
something.
Address 0.
Well, that would explain why address 0 was not doing anything.
Yeah.
And address 1.
And address 1. Yeah, there's 2 of them.
Yeah, so we might want to replace Z36 and then give it another go. But I mean, like, does this make sense for the CPU not moving? Like, is this
worth running down
No.
right now? Is this worth expending our effort?
That's just refresh. That's just refresh. So
Yeah, it just means that we have some memory ICs that aren't working.
yeah.
Or we have some parts of the memory IC that aren't working.
Yeah.
But we should be seeing, you know, idle or run or something, right?
Yes, we should.
And the fact that I'm not getting either says I think we've chased down power supply issues, we've chased down memory issues, and I don't think memory is the issue here. So I think now we chase down the idle and run light. It took us till midnight to get to your diagram, Richard, but we're getting to it. But the tricky part here is that I can't really get to anything. I can get to the memory controller board if I remove my RAM board here. So
I think for control we should be okay without it.
yeah, but I can't get to the CPU without removing the memory controller board. And even then I can only get to one of the CPU cards. I can only get to A1. I can't get to A2.
Right.
And I think, like, even if I had a riser card, it wouldn't make a difference because I have to have those connector pieces on the top.
Exactly. You would have to have connector cables to be able to jump those.
Yeah. So let's see if we can chase down our run indicator, or even just like the multiple clocks on the memory controller card.
Hang on 1 sec. I'm checking something here myself.
Yeah. Where are you? You're still in the memory controller. That's the item. Where's our memory controller? Good Lord Almighty, there's a lot of stuff going on with the controller. So I am just going to make a list of all the different names that say CLK in it and where I can check them. So ULRCLK is on Z0805 and 11. LLRCLK is on Z0805 pin 8. Makes sense. They both seem like they're the same thing. One's upper, one's lower. Good Lord. It's almost like the memory controller is more of a processor than the processor is.
Well, it's got its own set of ALUs too.
Yeah. Well, interestingly, they don't even call the CPU the CPU. They just call it the arithmetic unit. So.
Yeah.
That was common. Like the entire processor of the PDP-6 was called the arithmetic processor.
Yeah. The program counter, all that, the jump logic, all that stuff was on other cards. And it's the same way here.
Yep.
Yeah, if you had memory like base and extent registers, it was not uncommon to shove the entire effective address calculation and jump adder and things like that on the memory controller, or you just had a signal that said next instruction, and the memory controller would put it on the bus.
This clock is in a couple of places. So we'll just pick one here. Let's do
The reason that was usually done is because if you think about it, laying out like an ALU is a pain in the neck and very repetitive and irritating. And if you run into something, some layout issue in the memory incrementer and things like that, you really don't want to have to relay out, and you have to relay out the board. You don't have to do all that, slog through all those ALU condition lines and crap. So you put them on their own board and then shove all the hairy crap somewhere else.
Lord.
I also had an irritating thought. We're lucky that this is not a micro-coded processor, because then the idle lamp could be something like on the larger Vaxxon, where the idle lamp lit up when the microcode was in the idle loop. So if literally anything went wrong at that level, you wouldn't get an idle lamp. Thus, the debugging tree for no idle lamp was very, very wide.
Thankfully, we found that like the run and idle indicators here, one of them should be on all the time.
Yeah, this is not micro-coded, so
yeah.
That's why I
It
said
does
we're lucky that it's not.
It does have ROM for instruction decoding, but I don't know. But I don't know how deep it goes. This is the deepest I've gone into the 980 at all.
Yeah, okay. There were a lot of things that did that, and it sounds dumb at first, but if you think about it, you can interpret a mask ROM as a diode grid. And so if you put the opcode on the address lines, the output on the data lines can be all of your mode select bits. And so that's how you can that's how you can get opcode decoding for extremely cheap with just a mask ROM.
Yeah.
Yeah, the problem is this doesn't work with later ROMs where if you put voltage on a data line, things go poof. On a mask ROM, there's a hole physically blown somewhere on the die, and your current is not going to go anywhere. But if you try that with like an EEPROM, something's going to go bang.
Oh, you can still use a WE for encoding or decoding like that, but
yeah, you just got to use lower current, lower voltage, and you got to be a little bit more careful about it. Mask ROMs just give no crap.
That's a lot of clocks. Let's check what we can here.
Take a look at the Discord page. You can see clocks and where they're coming, what they are.
I mean, I found 1, 2, 3, 4, 5, 6, 7, 8 clocks, I think.
5, 6, 7, 8, 9, 10, 11, 12, including the oscillator.
Oh yeah, I didn't include the oscillator. And I didn't include the separated HS or the non-separated HS clock. I've got HS clock A and HS clock B.
Okay.
The 12 megahertz clock is separated out into 3 phases: P1, P2, P3, that are all 4 megahertz clocks.
Yeah, so I found HS clock A, HS clock B, C clock. I didn't find P1, P2, P3 because I wasn't looking for them. I found G clock, sys clock, and that's it. But I found some extras that aren't on here. Like I've got CPU CC. I don't know if that's actually a clock.
Oh, is it running, or you didn't check if it's running though, right?
I haven't checked if it's running yet, but
No, just looking at the schematics.
I've also got ULR clock and LLR clock. That's not on this list
Yeah, I
here.
was noticing that too. I saw that too.
All right. Well, let me check what I found,
G-clock,
and then we'll go hunting for more.
So sys clock is a free running clock. G clock is the gated clock. That sounds like the one, if I'm reading this right, that really goes to the CPU, or they're calling the arithmetic unit.
Yeah.
What is it gated by?
That's my ground. All right. Let's start with sys clock. That one sounds pretty important.
The two most important seem to be sys clock and G clock.
So we'll start with sys clock. Sys clock. That's going to be Z1203.
Z1203.
Which could be... No, it's definitely this guy down here. Okay, so that's gonna, it's X and then Y, not Y and then X. C1203 is where I'm gonna be picking up sys clock on, and that's on pin 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And instead of trying to hook up a bunch of probes at once, I'm just doing this thing one at a time here so that I don't break stuff. There we go. Let's hold you out of the way so you're not shorting on anything. All right, this is sys clock here. Totally dead. Is that right? Yeah, stuck at 0 volts.
Where's the logic for it? I haven't found it yet.
Let me double check that I'm in a good place, but yeah, let's... Sys clock seems like it's relatively important.
Yep.
So I was looking at it on Z1203, pin 11. So that would be page 14, kind of
14.
In the middle of a page after a bunch of D flip-flops.
Write, read. Sys
So-
clock. Found it.
Yeah, the clock for that is generated by HS clock A. So if HS clock
That-
A is not going, then sys clock is never going to go.
Did we check that last time? I forgot.
Well, we're going to check it right now.
We were looking at it. We were looking at it, but I don't remember how far we went with it. Step clock.
So
Stroke
HS clock A is Z07 12 pin 11. 07 12 pin 11. Oh 07 12 10 11 12 13 14. Yep. Oh, don't you pop off on me. So this is HS clock A. That is alive and fast and a little messy looking, but whatever. So HS clock A is being generated, which is the primary clock for the string of D flip-flops that generates system clock. So let's chase system clock backwards. Oh, which also generates P1, P2, and P3, by the way.
And P3 is inverted through two 7437s to give us G clock and sys clock.
Yeah.
Uh-huh.
So we have P3.
Let's move all the way back to
You've got
SRIN. Because if SRIN is not doing anything, well, no, maybe not. Because we're also clearing and setting via pin 4 and 10 or something. I don't know. Maybe let's just go backwards. Let's not get ahead of ourselves.
Yeah.
I think Adam's on the right track here. So we'll
0613 pin 9 which is the output of the divider. That's P3.
9. This is P3. Then P2 is Z0614.
Yeah.
Z0614 pin 9. And then P1 is Z0614 pin 5. All right, let's check all three of those.
All the set and clears go to a logic gate that's just named 1.
And 0. Or Ni. Nia?
All right. Z.
Yeah, so I think it's just not using set and clear.
1A, yeah.
13. There's Z0613.
Weird way of doing things, but
It's not the first time I've seen a logic gate being used as a voltage source.
There we go. There's
Still don't
Z06
know
pin
exactly
13.
why.
Or Z0613 pin 9.
What's fun is when you have a logic gate being used as a power source on a delay, And if you change the part and change the delay, things go
We have
crap.
Oh yeah, I hate those.
So Z06. So we have P1. We have P3 at the very least. We have Z06 13 pin 9.
Okay, that kind of indicates the other two are working.
Yeah, I mean they kind of have to be. Like P2 has to be working in order for P3 to go, right?
Yep.
Yeah, P1, P2, and P3 are delayed versions of each other. P3 is divided by 2.
Yeah,
Think?
and we've got
Oh.
P3. So let's go back up to
No
Z12
sys clock.
03 pin 12. Let's check the input into Z12. Make sure that we're getting, that we don't have a broken trace.
Yeah.
If pin 12 looks good, we'll check pin 11 again. If pin 11 is still bad, then that says that we've got a bad
Bad
IC,
gate.
right?
Or something else is shorting it to ground.
True, that's entirely possible.
Sys clock, that is.
Yeah, something could definitely be shorting sysclock to ground. What is this again? Z
1203.
1203 pin 12. There's 12, 3, and that's a 7437. Yeah.
Yeah. They actually labeled the chips there.
Look for 12. All right, there's 12.
Ain't got no nothing.
Well, I haven't turned it on yet.
Oh.
What page are you on again of the schematic?
Uh,
1203 pin 12.
Yeah, but 1203 pin 12 has nothing on it.
Ah,
Well, that's interesting.
but P3 does exist.
P3 does indeed exist. So either we've got a revision problem here, where the revision
Well,
of this
that's an
board
easy-
does
That's
our
an easy-
schematic have a number on it? 960777. Yeah, that matches mine, so I don't think we have a revision difference. All right. Let's check. Let me get the multimeter out here.
Wait, no, it's 90677 Rev E.
Oh, I don't have a rev number on this. It's just 960777 is all I've got.
Schematic, yeah, says revision E. Oh, wait a minute. Or is that an E size drawing?
Is it E size and Rev A? Maybe I'm backwards there.
All right. We know that P3 exists on Z06 13 pin 9. 06 13 pin 9.
Yeah, you're there is only Rev A. There's just one change. I can see it.
There's 9. Yeah, I do have a connection to pin 12.
And pin 9?
Yeah, and pin 9.
Okay.
That's weird.
What the heck is going on?
Check. Check pin 13, see if it goes straight to VCC. Pin 14.
I mean, we checked the input. There's only wire between those two,
Yeah.
and it buzzes out, but signal doesn't go.
Yeah, that's weird.
Yeah,
And
13 does go to VCC.
Okay.
Yeah, so at this point, maybe my probing situation is not great. So let's double check that we're not going crazy here. And I know it's going to take a second, but let's go back to 0613 pin 9.
I mean, this is not quantum computing.
All right. Let's double check. This is P3 on 0613 pin 9. And now I don't have P3. I got nothing. Oh, there it is. No, I had really not great connection on my probe, it seems.
Ah, okay.
Now we've got that going on there. So let's move up to let's check the output for sysclock again. Z1203 pin 11. I think I'm having trouble getting through the oxide layer on these chips. So 12-3 pin 11.
Yep.
All right. Nothing shorted out. All right, let's go on. Okay, that is a system clock. That one does exist now.
Okay.
So the existence of the system clock, oh man, look at that. I just barely touched the table and it went away. Yeah, it's a sketchy connection, but it's there.
I hope that's only the probes.
Yeah, and I think what's happening is that the legs of the IC have enough corrosion on them that my clips are not cutting through that corrosion very well.
Makes sense.
And that just sent us down a rabbit hole for a little bit. All right, so we've got system clock, which means that we also have P1, P2, P3. So we're good to go on that. We have HS clock A. So what'd you say, Adam?
G clock, gated clock.
Yeah, I'll check that one next. That's Z1203 pin 8, same chip. I mean, it's running. I can feel the 74181's getting warm.
They do that.
Yep. All right. So
Well,
G clock Z1203 pin 8. That is plugged into the correct place. All right. We do have a G clock.
Hey.
good.
All right.
Good. See if your step clock switch does anything to that signal on the front panel.
Nope.
Nope. Maybe maybe a switch issue. We did
mean,
talk about that last time too.
Yeah, but we checked
A
all
lot
the
of
switches
those-
and they were fine.
Oh, that's right. That's right.
Yeah, something else is gating G clock in a different place. Either that or our panel truly is locked.
Other thing that could be going on is since we don't have a halt light, it may be that signal only works in halt. And so it's being conditioned out.
All right, let's check C clock next. C clock is Z0511.
So you have G clock.
Yeah, we have G clock.
Okay, because that means then the stop clock should not be asserted.
Correct.
So it is running.
Yeah, it's doing something. The CPU is not running. All right, this is C clock. I don't know what C clock does, but I've got it. Ooh, boy, that is a hot mess.
Wow.
C clock is made from a boatload of things.
C clock apparently stands for crunk.
Sometimes it goes 0 to 2, and sometimes it goes 2 to 5.
Oh, that's weird.
Oh, because I've got a 60 hertz, 60 cycle hum going on is what I've got going on here.
Wow. Whoa.
Well, that's
Yeah.
not great.
Yeah, the question
We found
is
the main.
Bad ground.
yeah, means I've got a sketchy ground going on here. There we go. There it is. That's 0 to not quite 5 volts. That's not even, it's like 3.2, but that's enough for TTL.
Yeah.
C clock is a 83 nanosecond positive pulse, which occurs during each P1 pulse in the absence of memory cycles. C clock is
4 megahertz
oh,
on
sorry.
the money. What'd you say it was? 87 nanosecond or something?
83.
83 nanosecond. I'll measure it here.
C clock is inhibited during the second and third P1 pulses of a memory cycle. I threw it in the chat because it sounds kind of complex.
It's describing a NAN.
It's a 248 nanosecond C clock.
Huh. That may change when the CPU is operating, though.
I mean, it's not getting interrupted by the memory or something.
Well, yeah, it is. It is. If you at 12:51 a.m., Richard posted the timing diagram, and you can see it there. It takes a break in the middle of the cycle.
Yeah, but it just means that CYCQ0 and CYCQ1 are not getting anything than ones.
UCC is Z0804. Z08. Oh, that's a tough one to get to. Pin 3. don't know if I can do this one.
Before I have a Stack Overflow, what got us here? We were missing. We had G clock, but what were we missing?
Yeah, we're not missing anything. It was just bad probing.
Okay.
So I'm just checking anything that looks like a clock just to see if we are missing something.
Well, I think we're missing CYC Q0 and CYC Q1, but it might be something normal.
Oh, we also don't have CPU CC, but I don't know if that's actually a clock.
Would that be like CPU chip select?
Yeah, so we don't have CPU CC, whatever that is. I will check the ULR clock though. Z0805 or the LLR clock. We'll do that one. Yeah, LLR clock is also no good.
That takes a whole bunch of logic to get it to do anything too.
Well, maybe it's not. Maybe it's still my probe here.
A lot of ALU stuff.
Or not. No, I think that one is just low. Maybe. I don't know. I could be having probe issues here.
Confirmed, David is an alien.
I'm an alien?
Well, you're probing things.
All right. All right.
Uh-huh.
Yeah. Well, that one is stuck at about 3.5 volts. But it's not
That's
toggling. That's LLR clock.
Lower limit register clock. It's a specific signal used within privileged instruction feature. Yay. Oh.
Oh,
So it may not need to be toggling.
yeah.
All right. Well, it looks like we've got most of our clocks. So what's the next path that we run down here?
Good question.
Why did my ground probe melt?
Melt?
Yeah, that's interesting. That must have slipped over and shorted on something.
Uh-oh.
Yeah, I ruined one of these HP probes. That sucks. It was still making decent ground connection for a while there, though. That is probably why we were getting real flaky measurements for a while there. I gotta find a better
Did we
ground.
verify master reset?
We verified that it's not stuck low.
Okay, yeah, we talked about that before.
Yeah.
Cycle inhibit?
That would be fun.
I don't know where that one is.
Let's see.
Yeah, if it's not on the memory controller card,
You can't get to it, I know.
yeah. Which is unfortunate, because I'm pretty sure that we got problems on the CPU card. On one of the CPU cards, at least. Because it looks like, you know, the memory controller card is trying to refresh memory. It's, I mean, it's going through the motions.
Yeah.
We're generating all the clocks. We're sending those signals out. Now, I can't check anything on the CPU, but I can check stuff that's on the backplane. So if it's a signal that is available on the backplane, I can check it. But if it's on the backplane, that would imply that it's also available on the memory controller card. You guys get
Okay.
a lovely picture of the top of my head there. But I swear it feels
And
like
you
the
have
CPU
access
itself
to
is not running. What was that?
we're close to it. Yeah, we're close to the point where everything is good but the CPU.
Yeah. What the fuck was that? That was a huge noise. What the hell was that?
From the computer or outside?
I don't know. It sounded like something hit the wall. Was it the cats knocking stuff over?
That's what I was thinking.
Oh no, that one's asleep down there, so he's not
Also,
at
you
fault.
would find the thing on the floor, I assume.
Yeah, it also sounded like it came from within my room almost.
This
Is there a
is the
drastic
ghost.
temperature change? Is it settling?
Could have been that.
This is the ghost hunting portion of the broadcast.
Yeah. Well, I don't
Yeah,
see any
ghosts
cows
of the-
inside the fence. Well, things that go bump in the middle of the night.
He goes 100 miles an hour. He's green dynamite.
Ah.
All right.
All
So
right.
can you get to Z1013 on the memory controller?
I can get to anything on the memory controller. What is Z1013? CEN?
CEN?
Or PRE?
I'm looking for cycle inhibit.
Cycle, oh, it's CY inhibit. So pin 13?
Yeah. Yeah.
Yeah, Z10 pin 13, I can do that. It's Z10 13 pin 13. Okay. There we go. Slot that back in. Cycle inhibit. I'm assuming that prevents the CPU from running or something.
Yes.
Okay. Up we come. It's at 0.
But that's inhibiting.
Okay. So it's asserted. That's not good.
Yeah, and I don't think it's a probing issue.
Where in the schematic is that?
Page 14. See, that's generated by Z09 15, right above it.
It's in quadrant C3.
Thank you.
And what is that? Is that a NOR gate? What is a 74H11? I'm terrible at
H11.
demoralization.
It's a quad 2 input and, if I'm not mistaken.
Nope, that is definitely a 3 input.
3 input. Oh, okay, yeah.
Triple 3 input and, yeah.
Okay. So it's a 3 input and. So in order for cycle inhibit to go high, 9, 10, and 11 all have to be high.
One of them should be master reset.
I can actually, I think, just straight probe this one because it's the topmost chip. So I can check pin 8, 9, 10, and 11 on this one pretty easy, I think. All right, so pin 8. Oh, pin 8 is high. So I was just getting a bad connection on pin 13 on Z1013.
Wait, pin 3rd? Oh, pin 8. Oh, okay, I see.
Yeah, because
So
9,
wait,
10, 9, 10, and 11 are all high.
And then, so is that means cycle inhibit should be high?
Yeah.
Is it? Or is the chip dead?
Well, pin 13 on it is high. Yeah, I was just, this is, my clippy clip was just not making good connection.
Okay, that's good news then.
Yeah. So cycle inhibit is good.
We're running out of signals that could be screwing things up outside of the CPU.
Yeah. Yeah, we're definitely running out of signals. But I mean, like, if I check the connectors on the top of the CPU, there's 0 activity on them.
Yeah.
Some are high and some are low, but there's 0 activity on those, like, 2 boards, the little crossover boards that connect the CPU, 2 CPU cards to each other. Not a single one of those is twiddling. Some are high and some are low, but
Yeah.
so the CPU is, something's holding the CPU in like a perpetual state of reset or something.
And M reset we said is correct.
I mean,
Checked,
we can double check the reset signals just to be ultra sure here. I could check them on the backplane straight into the CPU, because we should have a master reset into the CPU from the backplane, right?
Yeah.
Yeah.
Got to figure out what pin that is. There we go. So there's the CPU. Does it list the signals on this page?
Oh, here's a dumb one. What's your clock switch in? What position?
Doesn't matter what position I put them in. Right now, it's in halt mode and the clock is off, but whether I switch on or whatever, there's no change on the front ever.
Okay, okay.
Could be our whole problem is on the front panel.
It's entirely possible, but you know, we're just kind of making random guesses. I would like to have a more kind of affirmative idea.
We did check HS clock, right?
Yeah, I checked HS clock A, and that was good.
Yeah.
Is the mode switch in run?
Right now, the mode switch is in halt, but it doesn't matter if it's in run or what, and nothing changes.
Well, put it to run and hit start.
I mean, I've tried that before, but...
Well, what I want to do is once you get there, then check the stop clock signal, if you can get to it, because that's on or going to AU1.
So where's the stop clock signal at?
That's what I'm looking for. Because I'm looking at the document that kind of describes this stuff in text, and I'm then trying to find it on the schematic.
Is that on the memory control board, or is that on...
AU1, no, it's not on memory control. I'm trying to see if it's on the backplane.
Oh, yeah. Do we have a list of signals on the backplane? I mean, I've got a picture of the backplane, but it doesn't tell me what the signals are.
No, that's all we got.
Did we? Oh, the other one is, did we check CPU CR? What was that doing? We did, right?
I checked CPU CC, but not CR.
Okay. That mean if that's pulsing, it means the CPU is requesting memory cycles. I'm guessing it's not.
Yeah, I don't think the CPU is doing anything.
Let me find the stop clock signal. Crap. I think it's only on AU1, which is not going to help us.
Is that front bezel with the lock unlock switch on it bolted on, or did they spot weld it?
Pretty sure it's spot welded on.
Damn it.
Well, it's bolted in some places. I might be able to pull it off, but I mean, I'm not sure what that gains us. Unless you want,
Well, access to
the front
it
panel.
would give us access to the front panel circuitry.
But I mean, like, what do we want to check on the front panel? Like, you know, we can get access to it, but we don't know what to probe.
Yeah. I don't know. I'm kind of at a loss at this point.
Yeah, I mean, we don't understand enough about how the system should work to know what we should be looking for.
Yeah.
It it really feels like the memory controller and the memory are trying to work.
Yeah.
But the CPU is not producing any activity.
Yeah, this is the oh god, like section or page 3-2. It starts to talk about all this stuff, and it does it as if it's telling a story. But that's where I'm kind of working my way through. But it gets real confusing real quick, and this is just text. There's no schematic here. There's the external stop clock, but that's not gonna help us.
The thing
Getting
is,
a lot of
if
drop.
I pull the memory controller board, then we get the idle light. So the memory controller board is pulling it out of idle, but not putting it into run. And I think we're getting the idle light because the idle light just has a pull up, and the memory board is pulling the idle thing low. Maybe. Although I think that maybe the idle indicator goes to the ALU, so. But the ALU is definitely not running without the memory board because this is the thing that generates the system clock.
Yeah.
Can you get to the AU1 backplane?
Yeah, I can get to anything on the backplane, man. I just need to know what to probe on the backplane.
So there's an external stop clock, pin 8 of AU1, the backplane connector.
You got to be a little more specific than that because we got P1, P2.
P1. Give me a second. I'm trying to find this. I believe it's P1 pin 8.
Okay. P1, 2, 4, 6. Okay. What are you expecting this to do?
Give me 1 second. It should be high.
It's definitely not.
So it is. That means that something is asserting the stop clock. Which points more to it being an issue on the CPU.
Yeah.
So that's, yeah, there's something going on. I mean,
I mean, you're
Unless we-
positive that it is. Oh wait, is it AU1 or AU2?
AU1.
Which one is that? I was on AU2. All right, hang on a sec. Let's check that again. Said it was P1 pin 8.
Yes.
Now that I'm on AU1 P1 pin 8.
Yes.
Okay, let's try again. That is high.
Okay.
Helps if I'm on the right card.
Sorry about that.
I didn't. It doesn't say what the cards are on the bottom, so I forgot to look up top to figure out which AU I was looking at. But yeah, that's almost a good clean 5 volts. Say AU1
Okay.
P1 pin 72 is what Richard's requesting, so let's get to that. AU1 P1 80 76 80 78 76 74 72 80 78 76 74 72. Okay. I'm not sure what this is checking, Richard, but it is also high. It's at like 3.5 volts, which should be enough for TTL.
Okay.
That is supposedly stop clock also. Okay. So the fact that it's high says that we're not stopping the clock.
So this, I'm looking at page, what the hell is this? 3-2. Basically, here on this page, they talk about the run flip flop and everything that has to happen to make that go. But I don't know if we can get to any of these signals.
Yeah, if it's not on the back plane, I can't really get to it. That's the cat. For sure this time. All right, Sue. You want to say hi to everybody? Let's say hi to everybody, buddy. Come on. There you go. All right. If you're going to be in here, you got to say hi. You gonna make biscuits on my arm? Hey, buddy.
Beauty cat.
Yep. Richard, I don't know if an extender card would help here. We would need an extender card plus big, massive ribbon cables that connect the two CPU cards to each other. Because the CPU cards also have like 160 connections on the top that go between them. That cat loves air conditioning. He's not coming in here to see me. He's coming in here to see the air conditioner.
I'm looking at, oh God, figure 3-5.
Me, sleepy one. Sounds like you now are the chosen human for 5 cats. Enjoy.
Yeah, my sister's currently taking care of 6.
Yeah, I don't really know where we go from here. I know that I'm getting sleepy though.
We're into stuff that's going to hit the CPU boards, and without having all that stuff you just described, the only way to probe on it would be pick a few signals, tack solder wires on, put it back together. It's pain.
And that's assuming that we had enough of a schematic to tell us where those signals are available.
Right.
Got a possible solution for the jumpers when you've got one on an extender. You could have an extender, if you could get the connector, make an extender board for...
Oh, I gotcha. Yeah, for the one that's still down.
Yeah.
Yeah, I'm picking up what you're putting down, but... yeah, that's getting...
But no schematics. That's the whole issue.
Well,
yeah,
we've
if you
got...
open up the... Sorry.
Well, we've got, like, I think Richard was talking about like volume 8, which kind of like describes where signals are on certain chips. I don't know. I haven't really looked at it yet.
If that data could be reliably OCR'd, somebody could make a Python script to make a schematic using KiCad, or that's a possibility, but I mean that's an awful lot of work.
Yeah. Turns out if you leave a computer outside for 30 years, it tends to not work.
Yeah.
I've never been so thoroughly defeated by a machine before.
This one is a rough one for sure.
Like, we definitely have something.
Go ahead.
Well, as you know, we definitely have something. At this point in time, I think the fault is, like, I'm moderately confident the fault is on the CPU and not on the memory control board. I mean, if we had any signs of life, we would have something to chase down, right? But we got nothing. Like the CPU, it's almost like the CPU is not even in the card cage, you know?
Yeah.
What is CPU cycle request doing? That's one that we could probe.
You're too late.
No, you don't have to do it now. I'm looking at what we could even, where the hell do we go next with the limitations we have? And how did TI do this back in the day?
They had schematics.
Yeah.
Well, I mean, did they have extender cards?
Yeah.
There might also be, certain signals you can test by removing one of the cards. Right. Kind of like what they were recommending doing on the power supply, where you remove one of the regulation cards and probe the other regulation card. And the whole thing won't work, but you'll see specific signals trying to do stuff, and that can tell you what's broken or not.
Well, if you do look at that, we're into the AU. What do you call it? PDF now. And if what page is this? 26. There is a 2-page spread of all the signals that have to be just right for it to go into run mode and stay in run mode.
So
so
clearly some of those are not right.
Yep. And this is just, I mean, while it is a schematic, it's just giving you signal names. There's no chip, there's no Z, whatever.
Yeah.
Oh boy.
So essentially, I think at this point, the only viable path forward here is to build the correct riser cards so we can probe the CPU.
Right. On a
I mean, I think
scale
that's the only thing that can happen. And then we need to figure out what on the CPU to probe.
Yeah, I've got an addendum to that statement about having a riser card. That wouldn't work if you're working on the back. That would be AU2, right?
Yeah.
The one in the back? Yeah. AU2, you wouldn't be able to get to anything.
Yeah, that's why the ribbons would be a better call.
Yeah.
Because you could kind of push the ribbons out of the way.
Yeah.
Yeah.
or we get ourselves a verification and test console, which probably doesn't exist anymore.
Yeah.
Nope.
Well, that's how TI did it. I'm digging through this document to see.
Yeah. Well, TI in Houston is now a bunch of apartment complexes and a mall.
Yeah. All right. Well, unless we have some incredible revelation between now and next Friday, I think we'll work on something else next Friday, just to get a win under my belt, man. Because it's been just like 7 episodes of losses on the TI-980.
Yeah.
Well, I agree. Next week, take a break from this, but actually, we have a working memory system. I think at this point.
Yeah, but
I'm taking the win where I can.
It doesn't mean anything.
It means the memory works. That's the memory's refreshing. Hey, it wasn't doing anything last week.
It remembered can't think. Yeah, that's good.
Memory is useless if you can't think about it.
Yeah.
But it's remembering the reset values that were put into it. It's refreshing.
Yeah.
And the other thing is we're eliminating a lot of variables. We're decreasing the amount of problem we have left.
Yeah, but we've decreased it into a place where we can't get to. Which is
can't get to yet.
Yeah. I mean, it's painful enough that we're now thinking about, oh, what if they were on flexible connectors? It's like, we went away from the Lytton for that specific reason.
Well, I mean, the good news is
ribbon cables.
They would be ribbons, but the difficult part is that, like, you know, getting a riser card here is going to probably be $200. Like, I tried to order it's tiny. It's the preamp for the BOMEM. It's like 60 millimeters by 80 millimeters, so it's like less than the 100 by 100 size that all of the PCB houses want you to do. So, like, I mean, it's tiny. The board cost was $2, and then the shipping cost was $95.
Oh my God!
Just to ship those guys to me. And so I actually ended up ordering through Osh Park because they were the cheapest, which is ridiculous. Like, I checked JLC PCB and PCBWay, and both of them were between $90 and $100 to ship. And then Osh Park, yeah, because Osh Park is located in the US, they ship it for free, but their board cost was $50. So and you only get 3 boards instead of 5. So for 3 PCBs that are 60 by 80 millimeters, I mean, we're talking almost the size of a like a credit card, like tiny PCBs that cost me $60. And yeah, it's insane. Like, I don't know how anybody's getting PCBs for cheap these days. Because I was like, yeah, it's 2-layer. Like, it's as simple as can be. It's the simplest. Like I said, the board cost was $2. All of the cost was shipping to me. It was, the shipping cost started at $45, and then they had an extra $50 surcharge for the fact that I'm in a rural location. Yeah. Yeah, which is why I ended up going through Oshpark. But if I have to get an extender board through Oshpark, that's going to be probably $200 to $300 because that's a big board, right?
Yeah.
So $200 to $300 through Oshpark, or $150 through one of the JLC guys plus $100 shipping. So I'm we're talking $200 to $300 just to get the raw PCBs here. Then I got to hunt down connectors, and I got to hunt down more connectors for the top thing. So I mean, it could be the fact that it's late and I'm feeling dejected, but like it wouldn't surprise me if to get an extender board onto this thing, I would end up investing $300 or $400 into it.
Okay, hear me out. The extender for the backplane for this is just straight pins, right?
Yeah.
Yeah.
Okay. You could just make your own extender out of something physically solid, like wood or something like that. And then the conducting can just be ribbon cables.
Yeah, we can
Just
do
ribbon
that.
cables with spacing for the length. That would save you the PCB entirely.
Well, we still need an edge connector to go into the card edge.
Yeah, you do, but that we can harvest from somewhere else if we need to.
Yeah, we could jankify our way through it to save some money for sure. Then that raises all sorts of different questions of like, if it doesn't work, does it not work because we jankified our way through it, or because something is broken?
Yeah.
You could do this on the Bridgeport if you really wanted to, but I don't know if there's enough signals that we have to get that crazy yet.
Yeah.
Between the ones that are the signals available on the backplane, and then if you do the tack solder thing for a handful of signals, it's not so bad, assuming you won't hurt the CPU boards by pulling them out and putting them back in a few times.
No, I can definitely do that, which is what I did on the 1144 power supply, which was tack fly leads off of it.
Yeah.
And so the best thing to do in that situation is for us to make like a really solid game plan that says we need to check these 15 signals. Let's tack a wire to this IC, this pin, this IC, this pin, this IC, this pin. And just make a list of things that we have to check. I'll tack all the wires to it. We slot the CPU card back in, and then I can go through and probe them one by one. I've done that before. I can do it. It's tedious. The hard part is like, if you tack one, you check it, and then you go, okay, now I need to trace that on the schematic, and then you got to shut it down, trace it, pull the thing out, remove that one, tack it to a different place, put it back in. And so to like check one signal path through 4 different ICs takes an hour or two, right?
Yeah.
So if we had if we had a really good game plan, like if we said, we know that the CPU should be doing this, 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 and this, and we should see squiggles on this, we should see a high level on this, we should see a low level on this, more squiggles on this one, right? And we just come up with a list of like what we're expecting to see, what ICs they are, what pins they are. Then, we do all the legwork not on live stream, because that's like a really tedious, slow thing to build that game plan. And then when we get on the live stream, boom, we tack all that, we check them all. That gives us a good idea of where we're headed. So we can do it that way. But like, I keep coming back to this, like we gotta have a game plan. Like we can't at this point in time, especially now, we can't be like, well, I think we should look at this signal, and then we check that one signal, and then we're out. Then like we hit a brick wall again. We gotta know like what the CPU is supposed to be doing, what the signals should look like for the majority of how the CPU should work, and where those signals are on the CPU card.
Right. And honestly, I didn't expect to be at the point where we're like everything's good with the CPU tonight. 2 weeks, I think, we could get some sort of a game plan together.
The other option we have is to do something like the test rig made for the Bendix, where we have a card slot that just has a bunch of switches for each signal, and we can set the signals up in a defined state, probe the board, and then flip the state. I mean, obviously, we're not going to be providing clocks fast enough to follow transitions in real time this way, but it would be good enough for testing the kind of stuff we're looking at now, and probably cheaper to do than an extender.
I mean, that circles back around to the same problem of we have to have like an extremely good knowledge of what the CPU is supposed to be doing.
Yeah,
right.
I'm just thinking we're gonna have to do that anyway. I don't think there's any way around that. I'm just thinking of avenues we can explore that don't involve dropping half a kilobuck on a PCB that should be a fraction of that.
Yeah. Most of that was me ranting about how the PCB houses are so expensive these days.
Everything is.
Yeah, I was shocked because it was like 2-3 years ago, that would have been $12 to my door, right?
Yeah.
And now it's $100. Like I was completely, and I was like, maybe it's a JLC PCB problem. And I checked on PCBWay, and it was the exact same shipping charges and everything.
Wow.
Yeah, it's an everything problem.
Yeah.
Hey, Dave,
I don't know if this is a case of
Yeah, what's up, Bob?
is there any chance that this is something stupid like a bad switch that's always asserting reset?
We checked that's a good question. We checked the front panel switches 3 weeks ago, and none of them were stuck because we were thinking the same thing you were thinking. And they all all the front panel switches for like run and halt and all that stuff were correct.
Yeah, not only that, we actually checked reset and saw that it was generating the reset pulse.
Yeah, that's right. Yeah. Yeah, I mean, like a large amount of it is trying to work. I just think that we have like a brutal fault on the CPU, and the CPU is an extremely complex, weird thing that we don't actually have the schematics for. So we're in this like awkward situation of like, how do we troubleshoot the bad or broken CPU? And I think Adam is kind of running down the correct path here of like understanding the theory of operation, and then trying to locate those signals.
Yeah.
And the other thing is it's got state. I mean, the whole thing I was saying to flip the run switch, even though it's not doing anything, I'm trying to get that flip flop into the right state. It's just like the oh god, the other computer you were working on before. My brain is so fried I can't even think of the name.
The
Data
900 whatever thing.
900.
Yeah, wasn't it like a 950 or 980 or something? The thing with the irritating person attached to it.
The 620.
That was it. All right. Well, I had the right number. It was just upside down.
Yeah. Immortal 468. The signals that we could check, we did see on the back plane that were coming from the switches as well. We could see the reset signal on the back plane correctly. So that meant that it was making it to all the edge connectors. S. Peterson, We can't turn the key because we don't have the key. So,
LGP21. That's what I was thinking of. Sorry.
oh, the LGP21, yeah, but we have the full schematics for that.
Right. What I was getting at is though you had to do a dance with switching modes once you to do an instruction.
Oh yeah, yeah. But I mean, the thing is like even if we have all the switches in the wrong places, or the switches are not working, or anything, I would expect there to be more lights on the front. The run indicator should be on, or the idle indicator should be on. The address lights or whatever should come up in some state, as opposed to no state. And then, you know, pressing some of the examine switches should do something. But I mean, maybe we're stuck in lock or something like that. But even if we're stuck in lock, it shouldn't matter. We should see something come on. We should at the very least see the idle or the run light come on, and we're not seeing either of those.
Right.
And I'm pretty sure that the idle and run indicators are controlled by the CPU, by the two AU boards, because Richard posted a schematic of the run indicator. But I'm pretty sure the idle indicator is also on the CPU board. And so if both of those are off, they're never supposed to both be off at the same time. But if both of those are off, that says that the CPU is never turning on. And so if we could probe the CPU moderately easily, we could check that. And I can probe the CPU if we remove the memory control board, but then the CPU is not running because the clocks are all being generated on the memory control board.
Okay,
The other thing is oh, go ahead. Go ahead.
This is that run flip flop I'm talking about. The thing on the far right of that is the run indicator.
Okay.
And then there's two more pages after that that are involved. But basically, if it starts to fetch an address from memory and it gets held up, or there's a breakpoint or anything, it seems like everything goes off.
Yeah, which I think is probably what's happening. It just sees something that it doesn't like and shuts everything down.
The other reason I
Oops, sorry. You go.
Yeah. Okay. The other reason I'm not convinced that we're still in halt, or I mean still in lock, is because the halt key worked, and I would expect the lock to disable that, because that would be a pretty destructive operation.
And did the halt key work?
Or the reset key? Sorry.
The reset. Key. Yeah, the reset key was generating the resets. Yeah, I don't think we're in lock. I mean, the key is not turned towards lock. But whether we're in lock or not, like, keep coming back to, like, we should get something on the front, and we're not getting anything. And so, I mean,
my gut feeling, kind of digging through this, is it's not finishing the first. It's getting through reset. It's not finishing the first fetch. Whatever the CPU has to do to complete grabbing that first address from memory, and it's getting pissed off.
Yeah. Which means that we have a fault on the CPU proper.
Right.
Which is a problem for future David.
Yep.
Yep.
What are we going to do next week?
I don't know. I don't know. My whole life is in flux at the moment, so.
Yeah.
Yeah. The bunny is doing better.
I know that feeling.
I will say the bunny's doing better. We're still struggling to get her to drink water as much as she should, but I mean she is drinking some. She should be drinking like 90 mils a day, and we're like struggling to get her to drink like 40 mils.
Wow.
Which is why her gut is getting so slow, and she's just it's like her gut is all dehydrated, but she doesn't feel dehydrated. So we're really struggling to get her to drink more. But other than that, she seems pretty good.
Keep producing urine.
Yeah, yeah. So I'm, and she's pooping a ton. Like she poops like 400 nuggets a day, which is what she should be doing, and she eats fine. But if she eats too much dry stuff, it starts to slow down in there, and then that produces gas, which makes her not want to eat, which produces more gas, which then goes into a downward spiral called GI stasis. So it's like she's on this like real delicate balance right now, where it's like if she drank a lot more water, we wouldn't have to worry about her at all. If she drinks a little bit less water, we're in like the danger zone. So it's like,
the chinchillas were like that too.
Yeah, it's really kind of frustrating. We're trying to do everything we can to like inspire her to drink. I think she got maybe 40 milliliters today, but like yesterday she was down to like 28 milliliters or something. We're like, that's just not enough. But she is getting fresh veggies, and that has a lot of water in it because we soak the veggies in water before we give them to her. So that helps. As for my mother, well, this is now on Twitch, but hooray. But as for my mother, she got through her 5th round of treatment and is showing signs of improvement. So that's good.
Good.
Oh, that's awesome.
Yeah.
Yeah.
It's I mean, it's still a terrible situation, but yeah. Yeah, she might come home next week, we're hoping. She might be able to come back home.
She's still pretty far away, right?
It's an hour and 20 to the hospital from here.
Oh, jeez.
Yeah. So I don't make that, Dad is making the trip regularly, and we're here, taking care of all of the animals, taking care of the ranch, taking care of everything. And so it's not really a stressful situation in that like I'm making the drive and I don't have time to do anything else. It's just like a stressful situation because it's a stressful situation, And whenever Dad comes back to the ranch, we make sure that everything's taken care of so that he can relax. Because he generally comes back for a night just to sleep in his own bed for a little bit, and then he goes right back the next day, and they'll stay in a hotel for 2 days or something up there. But he's coming back tomorrow night, and then I think he'll probably go back, and then I'll probably go visit Mom on Sunday. And then he'll probably go back up on Monday.
It's rough. It's don't get old.
Yeah. It's what's interesting is that like the myasthenia gravis is everything you read about it goes, it's non-hereditary. It's not hereditary. And I've only met 2 people in my entire life that have ever had this disease. One is my mother, and the other one was her father.
Oh.
Like, it's not hereditary, but the only 2 people that I've ever known that have ever had this, what are the odds of that, if it's not hereditary? So maybe there is some hereditary element.
That or it's environmental. They both lived in the same place, same conditions.
Maybe, I mean, he died when I was 8 from the disease. And so that was, 30 some odd years ago. And she didn't start showing symptoms of it until this year. And he died, they were living in Florida when he died. So, I mean, there could be some location aspect to it. Like, I don't know how long it can sit dormant before it decides to activate itself. But it's a neurological thing. So like, who knows? The brain is weird, man.
Yep.
Yeah.
Yeah. And on that somewhat interesting bombshell, I don't know. It's not depressing. It's just life. We're just getting through it.
You do what you can, one day at a time.
Yep.
Yeah.
But on that, we'll call it a night for the Twitch crowd. So thank you guys for joining. We'll see you next week, barring any insane things that happen in the next 7 days. Take it easy, guys.